complaining that something was too easy?
Well, it's because like I got the worst, and so I was making it more complicated.
Yeah, making it more complicated.
That tends to be a common problem in my class. When I do give you guys something easy, everybody does worse on it because they expect it to be hard.
Yeah.
See, I can't win. I can't be nice because you think it's too easy. Okay, let's start with problem 17. So the word problem, you guys didn't like that?
No.
Oh.
No, it's not the word problem, it's the way you have to solve it. The table C.
So, on the final, there will be a word problem. We did these like distance, mixture, interest problems. There's only going to be one. So it'll probably be like a distance or an interest problem. Interest we're doing right here. Distance, what's the distance formula? Rate times time equals distance.
That's area.
We're gonna have to like know that, right?
Yeah, you should know the distance.
Wait, what
So,
did you say? Sorry.
Rate times time equals distance.
Well, I knew that.
So the strategy is the same that we're setting up the table. If we look at this one, we are talking about interest. So principal times rate times time equals interest. Okay, we have a couple different things going on. We have an investment. He's doing some at 7%, some at 6%, and then we have a total. He has $22,000 to start with. So what is that number?
Your P.
Total P. We invest some at 7%. I don't know how much, so that is. And the rest goes at 6%. So that would be?
Your total minus X.
Rate. 7% would be? 6%. Okay, time. It said annual interest, so my time would just be 1 year. And we have an annual return of 1420, so that is?
Your total interest.
Total interest. So then, you've done the hard part. We are multiplying, just using the formula. Principal times rate times time equals interest. So x times 0.07 times 1 is 0.07x. Multiply the second one, so you get 0.06 times 22,000 minus x. Okay. So you have the interest from the first, the interest from the second, and the total. So that means you have to add the first two to equal your total. So there's your equation. Okay. So if we distribute 0.06 times 22,000, what does that give me? 1320, is that right?
So I don't have right answer.
Okay, combine like terms. 0.07 and negative 0.06 is 0.01. Subtract over your 1320, you get 100. Divide by 0.01, and you get 10,000. Then how do we have to answer? So Bob invests $10,000 at, looking up, X was my 7%. 22,000 minus 10,000 would be 12,000 at 6%. Okay. Is that one okay? Problem 19. So I want the zeros. Okay, so this is where you have to do your P's and Q's. The p's come from your constant, so everything that divides our constant evenly, which would be plus and minus 1, plus and minus 2. Q is from the leading coefficient, which was 4, so everything that divides 4 evenly, so plus and minus 1, plus and minus 2, plus and minus 4. Then you list your possible zeros. That's P over Q. So all of these get a plus and minus, so 1 over 1, 1 over 2, 1 over 4, 2 over 1, 2 over 2 is 1, which we already have, 2 over 4 is 1/2, which I already have. So that's it. Be prepared on the final for me to ask you to do all these steps. Find your possible zeros and go through that whole process. Now you have to find one that works. So it works if you plug it in and it makes the equation equal 0. Shortcut, if you're trying to find one, you get stuck, you can look at a graph and look at where it touches 0 and then check that one. So what works here? 2. So then we do synthetic division with 2. So our coefficients were 4, -4, -7, and -2. Remember, if you have a missing power of x, don't forget a 0. 4 comes down, multiply to 8, add 4, so this would be 8, 1, 2, and 0. What if that didn't equal 0?
We did something wrong.
Yeah, you did something wrong. It didn't work. Okay, so this is 4x squared plus 4x plus 1. That's something we can factor nicely, isn't it? So if we do box method, those multiply to 4 and add to 4. So what would that be? So factor, you get 2x and 1, 2x and 1. So I asked for a couple things. The factored form, we have this 2x plus 1 twice, so you could put 2x plus 1 squared. 2 was a 0, so what else has to be in here? How do I write my factor? Yep, you always do x minus your 0, so x minus 2. That's the factored form I asked for. The zeros, you just set each of those parentheses equal to 0. So this would be a -1/2. It was squared, so multiplicity 2, and my 2. Questions there? Number 20. So I want all the remaining zeros, and I told you that 2i was a 0. So I've given you the first one, so I've told you where to start your synthetic. So 1 comes down, 1 times 2i is 2i. These are not like terms, so when you add, it's just -4 plus 2i. Multiply. -4 times 2i is -8i. 2i times 2i is 4i squared, which is, so when you add, 4 and -4 drop out, and we have -8i. You multiply with 2i, you get -16i squared, which is +16, and we get 0. Okay, this is still pretty ugly, but if 2i is a 0, what else is? So we're going to do synthetic again with -2i and the answer we just got. So 1 times -2i is -2i. Add and we get -4. Multiply, that gives us an 8i. Add and we get 0. So this is our remainder, our constant, and x, so we're left with x minus 4 there. So our directions were just to find the remaining zeros. Okay, so I gave you 2i, so the other zeros were the -2i, and what makes x minus 4 0? +4. questions on that? 23 is asking you to graph, so you have to start with your parent function. It was an x squared, so 0 squared is 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. And then, what's my transformation here? So take each left and down. A minimum of 3 exact points. Okay, so your graph looks like that. Then I asked you for domain and range. So domain is left to right. Keep in mind this thing keeps extending both directions, so what would it be? Okay, my range. Right. It's bottom to top, so my lowest point is down here at negative 5. Goes up forever, so negative 5 to infinity. Then the increasing, decreasing constant. So as you go from left to right, this first section of my graph is falling, so that would be decreasing. You list the x values, so it's coming from negative infinity and stopping at negative 2. Technically, with increasing and decreasing, it doesn't matter if you do a parenthesis or a bracket. So you could have a parenthesis there, or you could have a bracket, either one. Then, starting at negative 2, what does my graph do? It increases from negative 2 to infinity. So the only time you use a y value is if you're talking about the range. Otherwise, you always list x's. Questions there?
So on number 22, is it decreasing from negative infinity to 0?
Uh-huh.
Okay, just making sure.
26. Oh, Mrs. Keller would be so mad if I told her you guys didn't remember this.
I did my multiplication wrong. I had my
I did.
When I was doing it, I was like, I know I'm doing something wrong. I know how to find the slope, but then I was like, do I put this
I don't want to
number?
visit the slope, man. No.
Alright, so how do we find the slope?
It's
y2 minus y1 over x2 minus x1.
So, make sure you know how to do that. Change in y over change in x. So negative 2 minus 4 over 3 minus negative 7. So we get negative 6 over positive 10, which is negative 3/5. Okay, to write the equation of a line, you need a point and a slope. There's my slope. We have 2 points, so pick one of them. Let's say I went with the second one. Now I'm going to plug into y equals mx plus b. So if I use the second one, my y is negative 2, my m is negative 3/5, x is 3, plus b. If I add over my 9/5, I get a negative 1/5. So my equation would be y equals negative 3/5 x minus 1/5.
I'm not getting it. I don't know what I'm doing. I picked the other point.
I just didn't.
Uh-huh.
I don't know what I'm doing. 3/5 times negative 7 plus b.
Okay, so if you did the other point, your y was 4, your m -3/5 times x plus b. So then if you subtract your 21/5, you should get a -1/5.
There we go. Got it.
Is that one alright? 27. Okay. So we have to start part A with factoring. So the top is x squared, really nothing to do with that, but the bottom you can do box method. Multiply -6 and add to +1.
-2 and 3.
Okay. B, x and y intercept. So the x-intercepts, that's when y equals 0. So when this whole fraction is 0. The shortcut is really just when the top of the fraction is 0. So what makes the top a 0? 0. Y-intercept. If you plug in a 0 for all of your x's, what do you get? 0. Okay, asymptotes. Vertical asymptotes. It's a vertical line, so I need the full equation. X equals whatever makes the bottom 0. So that would be a -3 and a +2. So 2 of them.
How did we get the y? How did we get the y intercept?
You plug in 0 for x. Okay, now we decide horizontal or oblique. What's the degree of the top?
2.
And the bottom?
2.
If the degree is the same, then the shortcut was just divide the leading coefficients. So you have a 1x squared and a 1x squared. So 1/1 is 1. So horizontal, y equals 1. You need to know those asymptote rules. Okay, I'll probably try to review that again tomorrow, but make sure you know those. Okay. Then, what else did I ask for? Okay, now we're going to graph it. So on your graph, I expect you to plot all the stuff you found. So the x-intercept and y-intercept were both 0. That's where we hit those axes. Put a point there. Vertical asymptote at -3, so a dashed line. +2. Horizontal at 1. And then you can use your calculator. Remember, when you put it in the calculator, you need parentheses around the entire top and around the entire bottom. And when you do that, I believe it's just something like that. So 28, part A. So our function is x minus 4 times x minus 2 times x plus 2 squared. First thing we're asked to do is the degree. The degree is essentially saying how many variables are there. So we have 1 here, and 2 here. So altogether it would be an x to the 4, so degree is 4. Second thing, end behavior. So if it's even degree, it looks like a parabola. So that means as long as it's a positive coefficient, it's up, up. Negative coefficient would be down, down. So this one would be
Up, up.
What if you weren't sure? How can you get it?
Graph it.
Yep, graph it and look. Okay, third one. Zeros and multiplicities. So 0, what makes x minus 4 0? Okay, what about x minus 2? And x plus 2? And since it was squared, okay. Then I want to know if the graph will cross or bounce at each. So it either goes through the point or bounces. So at 4 and 2, what's happening? Right, the graph goes through because it's an odd multiplicity. Here we have an even multiplicity, so the graph will bounce. Next thing, y-intercept. So that's saying if x equals 0, what do you get out? So if my x is 0, I get a negative 4 times a negative 2 times a 2 squared, and we get 32. Then you have to graph it. So I know at the end is up, up. So both of these then should be pointing up. I hit the x-axis at my zeros. So 4, 2, and negative 2. Y-axis at 32. I'm going to count by 8s. Okay, so my graph has to start up here. I hit my negative 2, and then what does the graph do at negative 2? Bounces. So it's going to come back up and hit my 32. Got to come down and hit my 2, and at 2 my graph goes through. Got to come back and hit my 4, and my graph goes through. So it looks like this, and my end behavior matches. Yes?
Can you explain again how you find the end behavior?
So it's all based off the degree.
Okay.
So even degrees look like parabolas. So either both ends are going the same direction.
And then if they're odd, then it will be like up, down, or
Yeah.
down.
Any other questions there? So B, this one is x cubed minus 4x squared. So degree, what's the highest power of x? 3. You notice the difference? On 28, I had to think about if I multiplied this out, what would my highest power of x be? And we said 4. But here, since it is just terms added together, you just take the highest exponent. Alright, second thing, in behavior. So if it's odd, it looks like a chair. Down, up. Negative coefficient would flip those ends. What's this one going to look like? Down, up. And again, if you weren't sure, what do? Graph it and see. Okay. Then number 3. I want the zeros. So we need to factor this to get that. What can I do here? I'll take out x squared, and that leaves me with x minus 4. So what makes this equal 0? It's just a plain x, that would be 0, since it was squared, multiplicity 2, and 4. Okay, will the graph go through or bounce? Remember, that's based off the multiplicity. So if it's an even, the graph will. 4 has an odd multiplicity, so it will go through. Okay, next we have to find the y-intercept. So that's if you plug in a 0 for all of your x's, what do you get out? 0. So we graph it. Should start down here and end up here. I'm hitting my x-axis at 0 and 4, y-axis at 0. So my graph starts down here. At 0, my graph will bounce, comes back down, hits this one, and it goes through. And so it matches what we said. And of course, you can always use your calculator to double check any of these. Is that one okay? Number 29 says more practice with our asymptotes. So, I want domain and all of the asymptotes. So part A. Start by factoring the bottom. So that would give me an x plus 2 over x plus 3, x minus 3. So the domain, what can x not be?
3.
4?
4. Oh. I thought you said 4. And I was like, no, I thought it was 3.
Sorry, I said or. So x can't be positive or negative 3. In general, I've told you if it's more than one value like this, you can just list it. If it's a single value, I want you to write the interval. Okay, asymptotes. So, vertical asymptotes are x equals whatever makes the bottom 0. So that would be? Yep. Your domain and your vertical asymptote are pretty much the same. The vertical asymptote is x equals and the domain is saying x can't be those. Now we have to decide horizontal or oblique, and that's based off the degree. The degree of the top is 1. The degree of the bottom is, if the top has a smaller degree, it's horizontal y equals 0. Okay. Let's look at B.
Wait, when is it y equals 0? At the bottom 0 to the top?
If the,
Top is
yes,
smaller.
if the top is smaller.
And then if it's one larger and the top is one larger, then what is it?
Oblique.
Okay.
And you have to do one.
Mm-hmm.
So it's only oblique if the top is large.
By 1.
By 1.
And if it's the same, you just divide the
Leading coefficient.
What if it's larger by like 5?
Then you say there's no horizontal or oblique.
Okay.
Okay.
Other questions there? Okay. So this one, nothing factors. Your domain, what can x not be?
2.
So since it's just one value, let's write the interval. So it would be negative infinity to 2 union 2 to infinity. Vertical asymptote, what makes the bottom 0? X equals 2. Okay, now we decide horizontal or oblique. It won't be both, it's one or the other. So the degree of the top is 2. The degree of the bottom is 1. So if the degree of the top is 1 bigger, then it is oblique. And we do long division. So the top goes inside. If you want, you might put a 0x just as a placeholder to help you. The bottom goes on the outside. Then we divide. So what is x squared divided by x? X. You multiply. X times x is x squared. X times negative 2. Negative 2x. And then what do I do? Okay, I distribute a negative. And then add, so I'm down to 2x plus 4. So you divide 2x divided by x.
2.
And that's all we need. We don't have to finish this. So it is oblique. Y equals x plus 2.
When do you finish them?
Only in a regular long division problem. With the oblique asymptotes, we always just find basically your mx plus b and then stop. Anything that I did not go over or that you're still confused with?
I have something, it's just like online.
Okay.
29A, I didn't factor it. I just did my best.
Oh, that's fine.
Okay, just to make sure
Yep.
if I do it that way.
No problem. Okay, so for tomorrow I'd like for you to finish it and then we'll go over those and then any extra time we can make up some other problems.